Hello, everyone, and welcome back to class. We are now on week 2 of the course. And I want to thank you for joining me this week as we are going to talk about a question that perplexes many educators. As when we learned last week during our sense-making unit that science is a tough topic to discuss with your learners. Learners at different age groups will perceive this topic in a variety of different ways. A elementary student would perceive this topic different than a middle school student, who is going to perceive it a lot different than a high school and early college student such as yourself. That topic is, how is science done, or what is science? Last week, we learned about the status of the scientific literacy in our region. And unfortunately, we're not doing exactly a great job at improving the scientific literacy. And that's probably because we do not have a good fundamental grasp on what the scientific method actually is. In fact, there's actually a method behind science. You may have heard of the scientific method in other media. And the scientific method is just basically documentation. We are in GSC 101, so we're preparing educators, developing lesson plans. Well, the lesson plan is just another form of documentation. So the scientific method is a set of steps that scientists use to be able to take a conceptual model, which is, let's say, a generalized observation and a question. Then collect enough data behind it so that way you can tie it into the physical world. We actually dabbled a little bit with this with last week's lab assignment and how we were able to develop a problem. So let's actually take a look at the scientific method real quick. And I'll have you do this in your lecture assignments this week. So right here, I have 2 beakers. I also have some molten salt and some ice. In the scientific method, we have a variety of different steps. And these are the steps that you'll be working on in this week's assignments, going from step 1 to step 2 to step 3 to step 4, and so on. And then ask yourself, is the scientific method a viable linear path of understanding that we can impart to our learners, or can we be more flexible with it? But I really wanted to show you the process of some of the key points in that scientific method. First point, observations. We want to be able to see something. And then we want to be able to ask a question as part of the hypothesis. So right here, again, I've got 2 beakers, got some salt, and some food coloring. My observation is that I see 2 beakers. One is going to be filled with regular room temperature water. The other beaker is going to be having ice and salt. Lots of ice, lots of salt. The reason why we use a lot of ice and salt in this is because we want to go and mimic the conditions in our oceans. I think that's a really great way to excite and engage your learner. And then we move into the hypothesis, or the educated guess. And this is where our wonders come into play. You ask your learner, what do you want to wonder about? And then that begins a discussion about the different variables that are assigned in a experimental design. So we have the two beakers of water. We got regular water that has nothing into it. We can consider this as a control group, and then we've got one with lots of ice, lots of salt, and then a simple wonder could be what color travels faster, red or blue? Ready? 1, 2, 3. And you can already watch that the water that doesn't have anything into it moves a lot faster than the simulated ocean water. And so that gives us a conclusion to our scientific study. And this is a pattern of logic that we can go and apply in the classroom with called the scientific method. This week in lab, we are going to expand upon the use of open educational resources and incorporate them into the classroom. One open educational resource is going to be using a virtual version of this device or tool that is commonly found in a lot of scientific labs, but can be incorporated in just about any classroom. And that is the microscope. The microscope is a really great tool for us to be able to understand the scale of science. Science occurs at a variety of different levels, and if we can connect our learners to the sense of scale around them, they are able to better perceive some of the topics that you'll encounter throughout your teaching career. Right here, I have a bright field microscope. We're going to go over in today's lab assignment for this the different components or parts of the microscope, such as the oculars, down to the objective lenses in the stage, even the lighting source, and how to focus it and maintain it. In this week's lab, we'll also take a look at some slides virtually. And how can we take the information or the sense of scale and then connect them to the wonders that our students may ask to us as educators. We are going to not only cover the parts of the microscope, but I also have an active learning exercise prepared just for you, where you can use a microscope to better investigate a piece of history. We'll be actually investigating as scientists and using the scientific method we learned in lecture and a virtual resource such as a virtual microscope to better understand the data that is being collected by an ancient shipwreck, the Mary Rose. I don't know about you, but I love learning about history, especially naval history. So if you have any questions, feel free to reach out. My email is always open. You can reach me out through not just email, but also Zoom, or swing by my office in room 208. Thank you and have an excellent day on planet Earth, and keep learning.